In this video, we'll be doing some examples of drawing aldehydes and ketones. So let's go ahead and start with the first example. I would again recommend that you try to draw them on your own. Pause the video first, draw them on your own, and then unpause to check your work. So we have 5-bromohexanal. We know from the AL ending that they're dealing with an aldehyde in this case because that's how aldehydes end. And so we have a 6-carbon aldehyde. I'm going to show you how to do both condensed and structural formula for this example. And then afterwards, you can just choose whichever one you want to do. I would get practice with both if I were you, just make sure you're on the right track. So we'll have our 6-carbon aldehyde. So 1, 2, 3, 4, 5, 6, with the carbonyl group at the end, like this, because that's how aldehydes are formed. And then at carbon number 5, so we start counting from this one here, 1, 2, 3, 4, 5, and so this would be 6. We have a bromine, bromohexanal, like this. And then you can go ahead and draw in your remaining H's, 3 there, 1 here, 2 here, 2 here, 2 here, and that would be the 5-bromohexanal. If you want to do this in the bond line diagram form, 1, 2, 3, 4, 5, 6. Double bond O over here. Make sure there's 6. 1, 2, 3, 4, 5, 6. Good. Carbon number 1 here, then 2, then 3, then 4, then 5, and then 6. And this is where our bromo is. So there we go. We just drew our first aldehyde. Okay, next we have one that's already drawn in. We have to name it. Notice the bond O is somewhere in the middle. So that means we have a ketone in this case. We're following ketone naming rules. So we have longest chain looks like it's going to be over here. Could have gone the other way, would have given you the same thing. Start numbering from the area that will give you the lowest number for everything, but especially for that ketone. It looks like going this direction would be best. 1, 2, 3, 4, because our ketone gets number 2 in that case. So that means at carbon number 3, we have a methyl. So 3 methyl. And then since we have 4 carbons, it's butan 2-one because it's on the second carbon. Butan, the carbonyls on the second carbon, 2-one, just like that. Okay, next we have a ketone. And I know that because it ends in -one. It's a 6-carbon ketone. And we have our carbonyl group at carbon number 3. Then we also have some substituents, chloro and iodo. So let's go ahead and draw our hexane 3-one. So 1, 2, 3, 4, 5, 6. And we'll number this way. It doesn't really matter from where. 1, 2, 3, 4, 5, 6. With our carbonyl group at carbon number 3. And then at carbon number 2, we have a chloro. And at carbon number 4, we have a iodo. Then you can plug in what you need. CH3, H. Here we already have all 4 bonds. Here we just need an H. Here we need H2. And then here we need H3. And so there we have it. 2 chloro, 4 iodo, hexane 3-one. If you want to draw it as a bond line diagram, 1, 2, 3, 4, 5, 6. Carbon number 3 is 1, 2, 3 over here. It doesn't really matter if it's facing down or not. Carbon number 2 has my chlorine on it. And carbon number 4 has my iodine on it. Okay, now let's go and take a look at the next example. You'll notice right away that you have 2 functional groups, one here and one here. And so based on what we learned, the aldehyde functional group, this carbonyl functional group, is higher in priority than the hydroxyl functional group. So that means that we have an aldehyde, and we should start counting from the carbon that has the aldehyde functional group. So 1, 2, 5, 6, 7, 8. So hydroxy and methyl, those are our substituents. We have to go alphabetical order when we're listing the substituents. So we have a 7-hydroxy, because H comes before M, 7-hydroxy. And then we have 3,7 dimethyl. And since there's 8, and it's the aldehyde, octanal. Next, we're going to go and draw a molecule from a name. So we have an aldehyde again because it ends in Al, and it's a parent chain with 5 carbons because of the pentanal. And it looks like we have some substituents, 3-chloro, 4-hydroxy. So let's go ahead and draw that pentanal. 1, 2, 3, 4, 5. Let's put the double bond OH here. So this is carbon number 1, 2, 3, 4, 5. On carbon number 3, there's a chloro. On carbon number 4, there's a hydroxy. And we can go put in our H's. H3, H, H, H2, and that is it. You can also draw your bond line diagram. 1, 2, 3, 4, 5. This would be carbon number 1 here. 2, 3. This is our chlorine. 4, and 5. This is our hydroxy. 3-chloro, 4-hydroxy, pentanal. All right. Next, we're going to draw butanone. This is a ketone. Interesting. So we have 4-carbon ketone. Notice that the butanone doesn't tell us where to put it. There's no number to tell us where the carbonyl group is. If there's no number, it basically means that it's only at the only place it can be at. And it doesn't really mean carbon number 1 here. When it comes to a ketone, you cannot have it at carbon number 1. You can have it close to carbon number 1. So, well, that's not true. For cyclic ketones, you actually can have them for carbon number 1. But for ketones that are chains, you cannot have them at carbon number 1, because if you do, then it's an aldehyde. So this is the only spot for a double bond to go. Because it doesn't make a difference whether we put it here or here, it'll still be butanone regardless, butan, 2-one, so to speak. You don't have to put the 2, technically, because someone would know, oh, the only place to make this a ketone would be if you put this on carbon number 2. So you can go ahead and draw that out like this. And there's your butanone, which is really the same thing as butan 2-one. I usually put my numbers all the time. You can omit it in this situation here because there's only one place it can be. But usually get into the habit of putting those numbers in, I put the numbers in. So let's just go ahead and draw this. 1, 2, 3, 4. And our double bond O is on carbon number 2. So 1, 2, 3, 4. There we go. Now we're going to draw the last one. The last one's interesting because it has 2 carbonyl groups. And so if you take a look at the naming rules, you'll notice that if you have more than 1 carbonyl group present, write the parent chain with ane, indicate all locations, and include the appropriate prefix finally ending in one. So we need to name this as if it were an alkane, for example, because there's no other double bonds. So this is our longest chain that contains both these carbonyl groups. It doesn't matter where we number from because we'll get the same numbers in both directions. So 1, 2, 3, 4, 5, 6. So we have a hexane, 2, 5 dione. And that would be the name for our ketone with 2 carbonyl groups. So that was just some practice for naming and drawing aldehydes and ketones. You have plenty of worksheets to try out. So please make sure you do get that practice to understand how to name these compounds. In the next video, we'll take a quick look at the properties of aldehydes and ketones.